On June 20, 2025, the Chinese commercial rocket company Landspace achieved a significant milestone by successfully conducting a static fire test of its reusable Zhuque-3 rocket. This event took place at the Dongfeng Commercial Space Innovation Test Zone located in Jiuquan, northwest China, and is a crucial step toward the rocket's anticipated orbital launch, which is tentatively scheduled for the third quarter of 2025. Static Fire Test Overview. The static fire test involved the ignition of 9 Tiangong 12A engines which utilize a methane-liquid oxygen propellant. During this test, the engines fired sequentially for a duration of 45 seconds, generating a total thrust of 7,542 knots. The test was designed to validate the first-stage propulsion system of the Zhuque-3 rocket and simulate ground conditions that closely resemble real flight scenarios. Landspace highlighted the test's high fidelity to actual flight conditions, stating that it rigorously covered all necessary steps in the pre-launch and flight sequence. These steps included propellant loading, tank pressurization, staged ignition, stable operation during the burn, and a programmed shutdown. This comprehensive approach was essential for ensuring that all subsystems, including engines, pressurization and delivery mechanisms, structural integrity and avionics, are compatible and function as intended. Technical specifications and rocket design. The Zhuque-3 rocket is approximately 66 meters in length and has a diameter of 4.5 meters with a liftoff weight estimated at around 570 metric tons. One of the key features of the Zhuque-3 is its first stage, which is designed for reuse at least 20 times. This reusability aims to significantly reduce launch costs by 80 to 90% when compared to traditional single-use rockets. The rocket's design includes a high-strength stainless steel storage tank and allows for the first stage engine to be checked without needing to detach it from the rocket after recovery. This design facilitates quick turnaround times similar to the operations of commercial aircraft, enabling the rocket to be refueled and prepared for subsequent flights. Future launch and development plans. The inaugural orbital flight of the Zhuque-3 is expected to carry a prototype of the reusable Haolong cargo spacecraft, which is being developed by the Chengdu Aircraft Design Institute. This mission is part of a broader initiative to provide low-cost cargo delivery services to the Tiangong space station. Notably, Landspace had previously conducted a successful 10-kilometer altitude test in September 2024, which was a significant step toward validating the rocket's capabilities. Looking ahead, Landspace plans to initiate recovery attempts in 2026, further advancing its reusable rocket technology and contributing to China's growing capabilities in space exploration and commercial launch services. Comparative analysis of coverage. The coverage of this event across various sources reveals some common points as well as differences in focus. 1. Common points. All sources agree on the importance of the static fire test as a critical milestone for the Zhuque-3's development. They highlight the test's successful validation of engine thrust capabilities and its simulation of flight conditions. 2. Differences. While some sources focus more on the technical specifications and potential launch timeline, others emphasize the automation level of the test and subsystem compatibility. Specific details about payload capacity were noted in some reports, while others provided more insight into the rocket's design features and reusability. Timeline of key events. October 2018, Landspace's first launch attempt with the Zhuque-1 ends in failure. July 2023, the Zhuque-2 successfully reaches orbit, becoming the first rocket to use methane-liquid oxygen propellant to do so. September 2024, a test flight involving a prototype first-stage rocket is conducted, reaching an altitude of 10 kilometers. June 20, 2025, successful static fire test of the Zhuque-3's first-stage propulsion system. Planned for Q3 2025, inaugural orbital launch of the Zhuque-3 carrying the Haolong cargo spacecraft prototype. Future plans. Recovery tests for the reusable first stage are scheduled to begin in 2026. Conclusion. The successful static fire test of the Zhuque-3 rocket represents a pivotal development in China's pursuit of reusable rocket technology. It positions Landspace as a competitive player in the commercial spaceflight sector, particularly in efforts to match or surpass the advancements made by established companies like SpaceX. As the company prepares for its upcoming orbital launch, the data and insights gained from this test will be invaluable in ensuring the success of future missions. The static fire test conducted by Landspace on June 20, 2025 for the Zhuque-3 rocket reveals several counterintuitive aspects regarding the progress and capabilities of China's commercial space sector. 1. Comparison to previous failures. Despite previous failures such as the Jiuquan launch in 2018, Landspace has shown remarkable resilience and learning capability. The Zhuque-2's successful orbital launch in July 2023 using the same methane-liquid oxygen propellant contrasts sharply with the initial setbacks. This progression illustrates the non-linear nature of technological development in aerospace, where initial failures can lead to subsequent successes rather than a straightforward path of improvement. 2. Reusable technology ambitions. While many in the space industry are skeptical about the feasibility of reusable rockets due to the complexities involved in recovery and refurbishment, Landspace design aims to reduce launch costs by 80 to 90% compared to traditional single-use rockets. This ambitious goal challenges the prevailing notion that reusable technology is inherently more expensive and complicated than expendable designs, suggesting that advancements in materials and engineering could make reusability more viable than previously thought. 3. Automated testing. The static fire test was described as China's largest and most automated 9-engine parallel cluster hot fire test to date. The automation level achieved during this test contradicts the common belief that high levels of automation in aerospace testing are primarily a feature of Western companies. China's investment in automation challenges the assumption that only established players like SpaceX can leverage advanced technology for testing and development. For cost versus capability, the rocket's specifications indicate that it can carry significant payloads up to 21,000 kilograms when expendable and 12,500 kilograms when recovered. However, the reduced height of the Zhuque-3 as compared to previous estimates suggests that initial flights may have lower payload capacities than anticipated. This counters the expectation that an increase in technology should directly correlate to increased capabilities, demonstrating that design adjustments often arise from practical testing and operational realities. 5. Public perception of competition. The narrative surrounding Landspace often positions it as a direct competitor to SpaceX. However, the realities of the commercial space market illustrate that while Landspace is inspired by SpaceX's successes, the Chinese context, including governmental support and market dynamics, creates a unique competitive environment. The assumption that competition in the aerospace sector operates similarly across different national contexts may not hold true, as state policies and funding can significantly impact a company's trajectory. 6. Testing as a risk management tool. The successful static fire test serves as a critical risk management tool, emphasizing how such tests can mitigate potential issues before actual flight. Many in the industry may assume that extensive testing is a sign of uncertainty about a rocket's design. However, it can also be interpreted as a proactive approach to ensuring reliability, which could ultimately lead to greater confidence in the rocket's capabilities. 7. Future plans for recovery. Landspace plans to initiate recovery tests in 2026, further illustrate a forward-thinking approach that contrasts with the immediate focus on launching. Many companies prioritize the launch itself over post-launch recovery. However, Landspace's emphasis on recovery aligns with a long-term vision for sustainability in space operations that may not be as prioritized in other commercial entities. In summary, the developments surrounding the Zhuque-3 rocket and Landspace's approach to its static fire test reveal a landscape that defies conventional wisdom regarding failures, costs, automation, competition, and the testing process in the aerospace industry. These counterintuitive insights provide a deeper understanding of the complexities involved in advancing space technology and the strategic decisions that companies like Landspace must navigate. The static fire test of the Zhuque-3 rocket conducted by Landspace is a pivotal moment not only for the company but also for the broader landscape of space exploration and commercial spaceflight, particularly in the context of reusable launch systems. While many reports cover the surface details of the test, several critical aspects may be overlooked by the general audience that are significant for understanding the implications of this development. 1. High degree of fidelity to actual flight conditions. One of the most significant yet underappreciated details of the static fire test is the emphasis on achieving a high degree of fidelity to actual flight conditions. Landspace stated that the test replicated the pre-launch and flight sequence with exceptional accuracy. This includes propellant loading, tank pressurization, sequential engine ignition, and stable operation followed by a programmed shutdown. Significance: this level of fidelity is crucial because it indicates that the systems are not only theoretically sound but also practically tested in conditions that closely mimic what will occur during an actual launch. Many rocket failures stem from discrepancies between expected and actual performance during critical phases. By demonstrating high fidelity, Landspace builds confidence in its technology, showcasing its readiness for the next stages of testing and eventual launch. 2. Automation in engine testing. Another noteworthy aspect that may be overlooked is the automation of the test process. The static fire test was noted as China's largest and most automated 9-engine parallel cluster hot fire test to date. Automation in rocket testing can significantly enhance the reliability of tests and reduce human error. Significance: high levels of automation suggest that Landspace is investing in advanced technologies that streamline rocket operations. This could lead to safer, more efficient launch procedures and is indicative of a broader trend in space technology where automation plays a key role in both ground and flight operations. As the industry moves toward more complex missions, the ability to automate tests and operations will be invaluable. 3. Cost reduction potential. The Zhuque-3 rocket aims to reduce launch costs by 80 to 90% compared to traditional single-use rockets. While this figure is often highlighted, the underlying mechanisms that enable this cost reduction are frequently glossed over. Significance: understanding how Landspace plans to achieve such significant cost savings is crucial for evaluating its impact on the commercial space industry. The design of the first stage, which can be reused at least 20 times and checked without separation from the rocket, exemplifies a shift towards sustainability in space operations. If successful, this could disrupt the market by making space access more affordable, leading to increased satellite launches and new ventures in space exploration. 4. Compatibility and subsystem verification. The static fire test also validated the compatibility between all major subsystems, including engines, pressurization and delivery systems, and avionics. This aspect, while mentioned, often does not receive the attention it deserves. Significance: the successful integration and verification of these subsystems are foundational for any rocket development program. Compatibility issues can lead to catastrophic failures if not addressed early. By demonstrating subsystem compatibility, Landspace mitigates risks associated with future launches which could otherwise be costly and damaging to its reputation and finances. 5. The broader competitive landscape. While reports often focus on the technical achievements of Landspace, the competitive implications of the Zhuque-3's development are substantial. The rocket is positioned to compete against established players like SpaceX, which has set high standards in reusable launch technology. Significance: the competition spurred by Landspace advancements could accelerate innovation across the industry, leading to better technologies and more affordable access to space. This competition is not merely beneficial for the companies involved but for the global economy and scientific community, as increased access to space can facilitate new technologies, research, and international collaborations. 6. Future recovery attempts. Landspace has plans to initiate recovery attempts in 2026 for the reusable first stage of the Zhuque-3. The focus on recovery is often treated as a distant goal rather than an integral part of the rocket's operational design. Significance: successful recovery of the first stage is crucial for realizing the full potential of reusable launch systems. It represents a significant engineering challenge and operational change that, if successful, could validate Landspace's entire business model. The ability to recover and reuse rocket components is what will differentiate the economics of space travel and could lead to a paradigm shift in how launches are conducted. Conclusion. In summary, while the static fire test of the Zhuque-3 rocket represents a significant technical achievement, the nuances behind this event reveal deeper implications for the future of space exploration and commercial launch capabilities. Understanding the high degree of fidelity to flight conditions, the role of automation, cost reduction mechanisms, subsystem compatibility, the competitive landscape, and future recovery plans provides a more comprehensive picture of the challenges and opportunities that lie ahead for Landspace and the global space industry. These elements are not just technical milestones, they represent the potential to reshape the very nature of access to space. 1. Significance of the static fire test. The static fire test conducted by Landspace on the Zhuque-3 rocket represents a crucial milestone in the development of reusable rocket technology in China. This test validated the performance of the 9 Tiangong K-12A engines, which are designed to use methane and liquid oxygen propellant. The test's success not only lays the foundation for the upcoming orbital launch but also highlights China's growing capabilities in commercial spaceflight, positioning Landspace as a competitive player alongside established companies like SpaceX. 2. Technical achievements and innovations. The Zhuque-3 rocket's design and the successful execution of the static fire test demonstrate significant technical advancements. The test closely simulated flight conditions covering various pre-launch and launch sequence steps, including propellant loading and engine ignition. The first-stage propulsion system's design allows for reusability up to 20 times, aiming to reduce launch costs by 80 to 90% compared to traditional rockets. This advancement in reusability is critical for the sustainability and affordability of space exploration. 3. Future launch plans and payload capacity. The inaugural flight of the Zhuque-3 is tentatively scheduled for the third quarter of 2025, where it will carry a prototype of the reusable Haolong cargo spacecraft. The anticipated payload capacity of the Zhuque-3, up to 21,000 kilograms to low Earth orbit when expendable, indicates its potential to support a variety of missions, including cargo delivery to the Tiangong space station. This capability aligns with China's broader objectives in space exploration and commercial satellite deployment. For context, within the global space industry, the development of the Zhuque-3 rocket and its successful test is not occurring in isolation. It reflects a broader trend in the global space industry towards reusable launch vehicles, with companies like SpaceX leading the charge. Landspace efforts illustrate China's determination to establish itself as a formidable player in this arena. The competitive landscape is further highlighted by the emergence of other Chinese startups aiming for similar milestones. Understanding this context is vital for analyzing the implications of China's advancements in space technology and their potential impact on the global market. 1. NASA's Space Shuttle Program. The Space Shuttle program, which operated from 1981 to 2011, is one of the most famous examples of reusable rocket technology. The shuttle featured a reusable orbiter and solid rocket boosters that could be refurbished and reused for multiple flights. The program allowed for significant advancements in space travel, including satellite deployment, construction of the International Space Station, and scientific research. Despite its successes, the program faced challenges, including the tragic losses of the Challenger in 1986 and Columbia in 2003, which raised safety concerns about reusable launch vehicles. 2. SpaceX's Falcon 9. SpaceX revolutionized the space industry with its Falcon 9 rocket, which features a reusable first stage. The rocket has successfully completed numerous flights since its initial launch in 2010. The first stage of the Falcon 9 is designed to land back on Earth after launch, allowing it to be refurbished and reused. This innovation has resulted in significantly reduced launch costs and has positioned SpaceX as a leader in the commercial spaceflight sector. The successful recovery and reuse of the Falcon 9's first stage have set a new standard for future rockets. 3. Blue Origin's New Shepard. Blue Origin developed the New Shepard rocket for suborbital space tourism. The rocket's reusable first stage is designed to be recovered after each flight, landing vertically back on Earth. Since its first successful flight in 2015, New Shepard has completed multiple missions, demonstrating the feasibility of reusing rocket components for commercial space travel. Blue Origin's approach to reusability has contributed to the emerging space tourism industry and has showcased the potential for reducing costs and increasing accessibility to space. The static fire test of the Zhuque-3 rocket by Landspace represents a significant advancement in China's commercial space sector, particularly in the realm of reusable rocket technology. As the company prepares for its inaugural orbital launch scheduled for the third quarter of 2025, several predictions can be made regarding the future of Landspace, the Zhuque-3 rocket, and the broader landscape of the global space industry. 1. Successful orbital launch and initial missions. The upcoming orbital launch of the Zhuque-3 rocket is expected to demonstrate the viability of reusable launch vehicles (RLVs) in the commercial sector. Should this mission succeed, it will solidify Landspace's position as a competitive player against established firms like SpaceX. The successful deployment of the Haolong cargo spacecraft prototype will likely lead to contracts for cargo delivery to the Tiangong space station and other commercial ventures, setting a precedent for future missions. 2. Enhanced reusability and cost reduction. With the Zhuque-3 designed for reuse, at least 20 times the potential for significant cost reductions in launching payloads into space is notable. If Landspace can achieve its goal of reducing launch costs by 80 to 90%, it will create a compelling economic incentive for satellite operators and other commercial entities to choose reusable options over traditional expendable rockets. This trend will likely accelerate the adoption of reusable rocket technologies across the industry, driving innovation and competition. 3. Increasing competition in the commercial space sector. As Landspace continues to develop its capabilities, it will be joined by other Chinese startups and established firms looking to capture market share in the burgeoning commercial space industry. Companies like Space Pioneer and CAS Space are also making strides with their own rockets, suggesting that the next few years will see a robust competitive environment in China. This increased competition could lead to faster advancements in technology, more frequent launches, and a wider array of services offered to clients. 4. Global implications and international collaboration. China's advancements in reusable rocket technology could foster international collaboration and competition in the global space race. As Landspace and other Chinese companies demonstrate successful launches and reusability, this might lead to partnerships with foreign entities sharing technology and expertise that can benefit both parties. Moreover, with the increasing involvement of private companies in space exploration, international regulatory frameworks may need to evolve to accommodate these new actors. 5. Technological innovations and future developments. The success of the Zhuque-3 Static Fire test and subsequent flights will likely spur further technological innovations. The use of methane-liquid oxygen engines, which are considered more efficient and environmentally friendly than traditional rocket fuels, may lead to advancements in propulsion technologies. This could open pathways for more sustainable space travel as the industry increasingly focuses on reducing its environmental impact. 6. Broader impacts on space exploration. As reusable rocket technology becomes more mainstream, it could significantly impact the future of space exploration. The ability to launch payloads at reduced costs will facilitate more frequent missions, including scientific research, lunar exploration, and even Mars missions. This democratization of space access may lead to a new era of discovery and innovation where more entities, including smaller nations and academic institutions, can participate in space exploration efforts. 7. Challenges ahead. Despite the promising outlook, Landspace and other companies will face several challenges. Achieving reliable recovery and reuse of rocket stages is no small feat and involves overcoming numerous technical hurdles. Additionally, the regulatory landscape for commercial space operations will need to adapt to the increasing frequency of launches and the integration of new technologies. Safety remains a paramount concern, as any failures could set back public confidence and investment in commercial space ventures. Conclusion. The successful static fire test of the Zhuque-3 rocket marks a pivotal moment in China's journey toward establishing a robust commercial space industry. With its potential for cost-effective and reusable space travel, Landspace is poised to play a crucial role in shaping the future of space exploration. The upcoming orbital launch will be closely watched, not only for its implications for Landspace but for the broader impact it will have on the global space industry. As competition increases and technological advancements continue, the next decade promises to be transformative for both commercial and scientific endeavors in space.